Okay, this is 4.3.1. And of course, we're still in trig here. And do you remember me telling you that if you have a circle and you always start with your initial side, is your starting side is like right there at 0 degrees, and then your other side is swinging like this. It's swinging open, and that'd be like a 30 degrees or pi over 6. This should feel easy now, I hope. 90 degrees or pi over what? Pi over 2, good. Let me straighten this one out. I know it's bothering somebody because I know it's bothering me. There we go. Okay, so this would be 180 or pi, right? Okay, so then this is called the terminal side. The side I'm moving, that's called the terminal side. So what if they say a point on the terminal side is -2, 4? You now can do a whole bunch of trig with that. What? The point here is -2, 4. Then really, if I stop my terminal side right there, superimpose over this in your mind the x and the y-axis. Do you get that -2, 4 goes over 2 and up 4? Do you get why that spot is -2, 4? Okay, now do you get that they just gave us two sides of a triangle? All right, so on your iPad, would you please label this? This is a really important example for the day. Like if you got this, you're pretty much getting everything I'm trying to teach you all in one spot, at least the first part of the lesson. This part's y, this part's x, therefore this part's -2 and this part is 4. The only thing that's messed up about this at all is that you can't have a negative side of a triangle in the real world. Do you get that? The length of the triangle can't really be negative on the side. All right, so just for a moment, imagine that that's just over 2 and up 4. I'm going to now remove my triangle from all of that craziness of the circle and everything. Do you get really what they just gave me was a triangle that has a side of 2 and a side of 4? And can't I figure out what the other side is? Yeah, Pythagorean theorem. So that's pretty easy. Do you remember the shortcut I told you? Always use the square root of. And in this case, do I subtract the other two things squared, or do I add the other two things squared? Add them. So it's 2 squared and 4 squared. So that's 16 plus 2 squared is 4. 16 plus 4 is 20. Square root of 20. Third side must be square root of 20. And do you get now that the important angle here is this guy? That's the angle that really matters. We don't care about the 90-degree angle that we formed right here, of course. The angle that's closest to the center, that's called the reference angle. You remember that? All right, so then this angle is the important angle. Now do you get, since I have all 3 sides of a triangle and I've got the angle, it's really very simple to tell me what sine of the angle is? Sine is the opposite of hypotenuse, 4 over root 20. The cosine of the angle. Cosine is ka, adjacent over hypotenuse. So that would be 2 over root 20, etc., etc. All right, one more thing. We're going to be a little fussy on the simplifying. Do you get that the square root of 20 can be simplified? It breaks down into root 20 is really, I like to write it as 2 roots, root 4 and root 5, and that's really then easier to see. Square root of 4 is really 2 root 5. So I'm going to start using 2 root 5 instead of the 20. It's just some of the small stuff that you got to know. So simplifying root 20 down into 2 root 5 was important. Okay, so now they would ask you to give, all they really give you is a point, and then they ask you for all 6 trig functions of the reference angle theta. It sounds really scary. You just got a point and you're supposed to get all these angles, but really what they gave you is 2 sides of a triangle. If they give you 2 sides of the triangle, it's not that hard to do. You find the third side, that's easy. And then if I want to find sine of that angle, I don't even know what the angle is. I don't even care. I just want sine of that angle. Sine of it is opposite over hypotenuse, so that will be 4 over hypotenuse, which is 2 root 5. There we go. There's sine of it. The flippin' sister of that is pretty easy. Cosecant. So CSC of theta would be to flip that 2 root 5 over 4. Good question. Yeah, I should really simplify that. Sorry. 2 goes into both of them. 2 goes in here once. And 2 goes in here twice. So sorry, that's 2 over root 5 once I simplify it. And over here, 2 goes into both of those. 2 goes in here once. Goes in there twice. Root 5 over 2. You know what? We could actually simplify our triangle, couldn't we? It's 2 and 4 and 2 root 5. I could simplify that. 2 goes into this once, 2 goes into this twice, and 2 goes into this once. Now it's a 1 and a 2 and a root 5. That way I won't have to simplify all the answers. I can just simplify the source. And from there, when I'm doing my sines, cosines, and stuff, it'll be easier. All right, next one's cosine of theta. Cosine is adjacent over hypotenuse. From this angle's perspective, the adjacent one is a 1, and then it's a square root of 5. 1 over square root of 5. And then the flip and sister of that is secant, and so you just flip it over. And why don't you finish the last two? Now all 6, so you'll have all 6 of them then. All right, now this is an important part. Some people feel like when they stare deeply into the board and they listen to me, that they're doing a good job in class. You really aren't. Sadly, you're only going to remember 10% of what I tell you today. What I tell you today. You will remember 80% of what you do today, okay, by tomorrow. And then the forgetting curve starts. Again, of course, you wouldn't remember on 100 years from now. We did. Unless you repeated it several times in longer and longer intervals, you could remember. If I told you the name Zippity-Doo-Dah, if I never say that again, and I ask you on the last day of school, some of you would just force it into your brain and try to remind yourself, right? But that's the point. If you remind yourself of it, you'd remember that word. Okay? If you remind yourself in a week what that word was, it lasts a couple weeks. Remind yourself in a couple weeks later, then it lasts for another month. Remind yourself again a month later, it lasts for like 2 months. And the point is, there's a forgetting curve. And if you right now don't write these down with me, then you are going to forget 90% of it. And 10% of it is not enough to get an A in this class. That's for sure. So that's why I'm so tough. And I know some of you are new to me, and I'm going to have to start cracking down on you because you're not writing things down when I ask you to. Because if you don't write it down, you aren't going to remember it. So if I ask you to do the problem, I really want you to do the problem. And if you don't know the answers, at least write out sine theta, cosine theta, and get the framework of the problem there. So if somebody is going to help you, it'll go faster. All right, so let's finish that one up. Cosine we had, so then the one that goes across from cosine is secant, and that's a flip, so it's root 5 over 1. And now I'd like you to compare with the person just on the last one what tangent of theta is going to be and cotangent of theta. And again, that's in this triangle right here. And I know it's a little messy, but yours should be cleaner than mine. You're just going to compare across the aisle. Your 2 rows are going to compare across. Your 2 rows are going to compare across, except here it gets a little messy. So we're going to go, you 3, please compare with each other. And now you 2 compare with each other because we don't have people across. And then you guys compare across the row. Please compare with them. Help them if they don't get it. Okay, seems like you guys are quiet now, which means you probably are done. Tangent. Tangent is TOA. I could put my little helper monkeys here if I wanted to. O over A. And the opposite from this angle right here would be 2 over the adjacent would be 1. 2 over 1, which is 2. And then it flips to 1/2. Raise your hand if you had those right. Okay, good. Now, I gave you a lot of the help at the beginning that made this easy. I'm now going to try one where I just tell you a point. And you have to draw the picture and figure out, well, where is that point? Just to start with, if I had said -2 comma -5, think, where's that point? -2, -5. -2, -5. It's right there. Now, You know two sides of a triangle. You know what angle is important. Instead of asking for all six, which gets a little tedious, I'd like to just find sine and cosine of the important angle. Sine of theta. Theta is always what we use for the angle we don't know. And cosine of theta. Draw yourself a triangle around that. Again, it was -2, -5. I'll pause for a second while you give that one a shot. So for those at home, I think these guys compare with each other and have it. Let me see if you have it, those of you at home. This one's the theta. That's the important angle. And this side right here is a 5. I know it's a -5, but since it's a triangle that's in the real world, I want to have it to have a positive side for right now. You do need to understand that that's negative and that's important. Okay, so back to this is -2 and this is -5, but again, we're going to call them 2 and 5. So when we figure this out, it's the square root of those things added, 25 and 4, and that makes 29, square root of 29. Can you simplify square root of 29? Okay, because 9 times 3 is 27, and that'd be a very easy mistake to make. But yeah, 29 is not going to work out nice with any perfect squares in there. So we're ready to do it. Sine of this angle, sine is opposite over hypotenuse. Okay, sine is opposite over hypotenuse. Now, -5 over positive square root 29. Now, I was telling you before, I was kind of wishy-washy on, I understand that in the real world, a triangle cannot have a negative side. So did any of you give the answer as a negative? Okay, several of you did. All right, I want you to think about sine of an angle. Do you know that sine is a wave? How many of you know that sine is a wave that kind of looks like that when you graph it? How many of you know that? Okay, many of you knew that, but not all. Do you get that sine is sometimes positive and is sometimes negative? Look at how it drops underneath 0. When it goes down in here, sine's negative in that little zone. Okay, so my answers, if I changed everything to positives, because, you know, well, a real triangle has sides that are actually positive. If I change everything to positives like that, do you get I would never get a negative answer? If I always clean these up and make them into positive numbers? Okay, so don't. You do need to leave them as negative in your calculations. This answer is -5 over square root of 29. I know I was not clear on that before. I was trying to make a point that in a real world problem, you wouldn't want to say the answer to this problem is -2. But in trig, we have to use those sides' direction, like the negativeness is important. Otherwise, when sine goes down into the negatives here, you'd never get a negative answer if you always make your triangle lengths have positive numbers. One thing that's always defined as positive, though, is the hypotenuse. Otherwise, we would add 2 negatives, which would have canceled, and we'd have it positive. So your hypotenuses are always going to be positive. But your other sides, they are negative in some cases, in many cases. Okay, so then cosine of this. Cosine is ca, adjacent over hypotenuse. Again, totally okay to have that there as a little help. And cosine is adjacent. What's the adjacent one to this? That. Over the hypotenuse, which is that. So -2 over root 29. Okay. So let's give you one more, and I'll ask you to find one of the weirder ones, the sister functions. So let's say I had a point of -1, 1. You know where that is. Draw that. Draw the triangle that goes with it, and find me the cotangent of that angle. If I were you, the first thing I would find is the sister function, but anyway, find me the cotangent of theta if my point's at -1, 1. This is hard enough to be an R3 level question on your next test. I looked, and your next test isn't until like the 23rd of February or something, so we are already at the 5th here, but we have a fairly long time before your next test. We have Heart Week in there, which gets a little bit crazy. You know, some of you guys will be buying out of school on that Friday. Be a lot of chances for you if you haven't, if you're new to the school, you'll find out you can buy out of classes on that last day if you want to, and the dollar amount that you pay to go play broom ball or go play trench or go watch a movie or whatever, it goes to charity, and it's a good cause. I encourage you to do it. What other day do you get to pick some other activity to go to instead of going to math class? Now, if on that day you're here, I will teach you math. If that's your choice of what you want to do, I'll do some math with you. But if I were a kid, I'd be opting for the buyout. And the last thought on that, if you're thinking, man, that's really cruel that people have no money, if you just go see the counselor, they'll give you magic money, which buys you out. So don't worry. Kids that don't have any money to donate, they'll get the buyout too. Okay, so where is this thing? -1, 1. -1 goes over this way and then up 1. All right, I made it really small. I could make my -1 bigger than that. -1's like over here and +1's like over here. So I'm going to put it there. Okay? Just so I can have a bigger triangle. Then, hopefully, you drew this and said -1 on it. And this is +1. And then what's the radius on that? Ooh, I know this one. 1 and the square root of 2. That means I know the angle too. That's kind of cool. You get what I mean? What angle is it? It's got to be a 45. Now, it doesn't matter really that that's 45 because they're not asking me for the angle. They asked what's cotangent of the angle. Do you get the difference? The angle would go right there. They don't want that. They want the side ratios. So cotangent of this. Well, instead of doing cotangent, I'm going to be a rebel. I'm going to do tangent. Tangent of that is opposite over adjacent, which is 1 over -1. But then I got to flip it. It's -1 over +1. And either way, the answer comes out to -1. Raise your hand if you had that one right. Awesome, that's most of you. All right, next concept, coterminal. I mentioned it the other day. Let's see if anybody remembers it. Coterminal means they have the same terminal side. If you were cohabitating with somebody, you have the same habitation. So if you live at home with mom and dad, or live at home with just your sister, whatever, you are cohabitating with them. If you are coterminal, then that means you are in the same exact spot as the terminal side. So like, okay, here's the terminal side. I decided to stop it at right there, which is about 30, okay? You get this is 30 degrees, right? And that's also, what's the radians for that? 5/6, good. What's coterminal to that? 7π/6. Let me see. It's a good guess. I don't think you're right, though. 6π/6 is right here. 7π/6 is right there. I know what you were going for. You were going for wrap all the way around and hit there, but you missed. This would be 12π/6. 13π/6. You are correct. 13π/6. Ah! I'm having trouble writing 13. 13π/6 is coterminal with π/6. How about, to get to the same spot, couldn't I have gone around this way? -330 degrees. Or what would that be in radians to go negative, to go this way? Negative, yes, that's it. -11π/6. Those are all cohabitating. No, coterminal. They're in the same terminal spot. All right, coterminal is easy. It's just angles that are in the same spot as each other. All right, so give me another way to say that is, give me another way to get right here. What's another way to get there than to go the way I went? Close. We want to go this way, 3π/2, so -3π/2 is coterminal to 90 degrees, also known as pi over 2. So negative 3 pi over 2 and pi over 2 are in the same spot. Just a different way to get there. I could even go the same way, but go further. So instead of stopping here, I could go all the way around again, which would be pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. Is another one that's in the same spot. 5 pi over 2. Now, how can you have the same angle giving you, like getting you to this, like different angles getting you to the same place? It's because in the end, you remember me talking about how its sine is a wave? Do you get, if these are angles along here, this is 0 degrees, and this is 2 pi, and this is pi, also known as 180, and this is pi over 2 right here. Do you get that there's a couple ways where sine is equal to 1? It hits one right here, and it also hits one right there. There's a lot of angles. In fact, if I want to keep that wave going, there's an infinite number of angles that are right there. It touches 1 at pi over 2, and at, this one's a little past 2 pi. It's 2 pi plus another half, so that's 3 pi. No, wait, this one's 3 pi over 2, sorry. This would be at 5 pi over 2 right there. And it keeps touching it here, and it touches it there, and it'll keep touching 1 over and over and over again. That's why there's a lot of ways you can get to the same answer. All right, I know your brain is starting to expand here, and I'm pushing you a little bit, but all right, that's coterminal. Next topic. Oh, by the way, how could you have an answer that's undefined? All right. You get that undefined is like what you get whenever you divide by 0? Okay. So that's like trying to ask you to find something that doesn't exist. All right. And the same thing can happen in trig. Like, for instance, do you get, if sine goes like this, then what's the highest that sine ever gets to if this is 1? What's the, isn't it 1? So what if I asked you to find, tell me when sine is equal to 2? It never is. It's impossible. Because sine only goes to 1. Well, how about if we do it in the context of the triangles we were talking about there? Let's say I asked you sine of some angle is equal to 2. Do you get that I just told you to do the opposite side is 2, and the hypotenuse side will be 1? Can you make a triangle? It's a right triangle, where the hypotenuse is the smallest side in the triangle? You can't. It's impossible. I'm asking you to do something that doesn't exist. So sometimes there are answers to your trig questions, which are DNE, does not exist, or undefined. And then we're going to, we don't get picky about how you say it, but basically, I can't do that. Okay? So, same again with the sine. Do you picture sine if it goes like this, back and forth and back and forth? Unless I stretch it or something, if I asked you to get sine to be negative 1.5, or negative 3 over 2, is that possible? No, because what's the lowest sine ever goes? There, the lowest it would be is negative 1. Highest it is 1. And so I can't get lower than negative 1. So if they ask me to make sine to be negative 1.5, I can't. What's negative 1.5? Negative 3 over 2. Can sine be negative 1? Yeah, sine can be negative 1. See? Touches it right there. But it can't be negative 1.5. All right, so there are things that are impossible, and you can say does not exist or undefined in trig. Okay. Next. Given the interval of values for an angle, state the sign, positive or negative, of each trig function. This sounds really complicated. Between 0 and pi over 2. The question is, between 0 and pi over 2, is sine, cosine, and tangent going to be positive or negative? All right. I have something for you on this that's going to be, you're going to use this so many times in trig. ASTC. Everybody write that down for yourself. All students take calc. That is our goal. Our goal is that we get all of our students out of this school taking calc. We don't always succeed in that. There's some kids that won't ever make it there. But it would be our goal that all students take calc. All right, but it's obviously not, you know, mathematically something that's important. But ASTC stands for, in this zone right here, all the functions always stay positive. Think about it. Remember we talked about those triangles, and if triangles ever had a negative side on them, that's going to make your answer negative? Well, if you're a triangle and you're in this little zone here, do you get that the sides are always positive? And therefore, all of your functions are positive. Sine, cosine, and tangent are all pos in that zone. Well, what's that zone between? That zone's between 0 and pi. Over 2, sorry. Wait a minute, that's not. Pi over 2, sorry. Between 0 and pi over 2, they're all positive. Okay, let's take away the all students take calc thing and just say A, S, T, and C. If A stands for all of them, S stands for sine. Now, what is sine? Is sine the only one that's positive, or is sine the only one that's negative? Let me show you. I'm going to draw a triangle here, and this one would be like, let's say this side was -1 and this side was 1. This angle right here we call theta. If I do sine of it, isn't it opposite over hypotenuse? Hypotenuses always have to be positive, right? So do you get, would sine in this quadrant be positive or negative? Positive, because sine is opposite over hypotenuse. Opposite over hypotenuse, they're both positive, aren't they? All right, so on all students take calc, what we're doing is giving you a list of which ones are positive where. So all of them are positive in this zone. Only sine is positive in this zone between pi over 2 and pi. Only sine is positive. This one's pi, right? So between pi over 2 and pi, only sine is positive. Why? Because if I do cosine, I'm going to use a negative number, right? And if I use tangent, I'll have to use the negative number again. Tangent is opposite over adjacent, right? So in this quadrant, if you were to draw the triangle here, they'd both be negative, and then only tangent's going to be positive, because when you do these two divided by each other, they cancel each other out. So even though there's negatives, there was 2 negatives, and so it cancels and becomes positive. So only tangent is positive in this zone, and only cosine is positive in this zone between 3 pi over 2 and 2 pi. Only cosine is positive in there. Okay, so if a question were to say, given the interval, state the sign of each trig function, and they say between 0 and pi over 2, state the sign of each trig function. Sine of theta would be what? Pos or neg. Cosine of theta would be pos or neg. And tangent of theta would be pos or neg. So now that you see that, I hope that seems like a fairly easy question. So if I'm in 0 to pi over 2, do you get I'm in this zone right here? What's sine in that zone? Positive. What's cosine in that zone? Positive. What's tangent in that zone? Positive. That's it. What if I change the zone? What if I say between pi over 2 and pi? Well, I can do all students take calc, right? Where am I? Between pi over 2 and pi. I'm in here. And which is the only one that's positive? Sine. So that's positive. Everything else is negative. The idea? Okay, so if you memorize ASTC, you got a lot of things to memorize for Precalc. You really do. You got to memorize all those common angles, you know, pi over 4. You got to go 45. And you got to be able to say ASTC. And right away go, okay, all students take calc. That means all of them. Sine, take is tangent. Calc is cosine. And you got to be able to say, where is cosine negative? And you got to be able, oh, I can picture that. ASTC, cosine's positive here. So all of them are positive here. So cosine must be negative here and here. Anyway, the point is you're going to have to memorize a bunch of things. ASTC is a big one. Yes, sir. Yes, you could. Please stick with me on the, yes, you could do CAST, you could do TCAS, you could do, you know, there's a million ways you could do it. But we number the quadrants in this order. Do you agree? This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And therefore, it makes more sense to go in the order that we do ASTC. That's why we do it in that order. Okay. All right. So, we've covered almost everything that you need to know. I could say, here's an angle. What point could be on it? 45-degree angle. Everybody draw it. You know where 45 is, right? Which of these 3 points could be on it? 1 comma square root of 2. 2 comma 2. Or 0 comma 1. Well, if you know where 45-degree angle is, you go like this. The dot that's here, could it be 1 comma root 2? Could it be 2 comma 2? Yes. Because we know it's a 45-degree angle. It could be 2 comma 2. This side and this side could be equal to each other. In fact, they are equal to each other. And therefore, that's the only point that could work. Bingo. See what I mean? I'll give you another one like that. Here's an angle. Given a, let me think. Given an angle of 3 pi over 2, which of these points could be on it? 1 comma 0, 0 comma 1, 1 comma 1, or negative 1 comma 1. It's a tough one. Come on, think outside the box. Nobody? You know where 3 pi over 2 is, don't you? Okay. Okay, thank you for taking a shot. Nope. Nope. Come on, I said think outside the box. None of them. You're right. None of the above. That's cruel, I know. But if you knew it was going down here, you should have said, well, the only thing that could be on there is like what? What comma what? 0 comma negative 1. All right, and that wasn't one of the choices. Okay, or 0 comma negative 2, or 0 comma negative 0 comma something, right? All right. Okay, so that's the last kind of problem that you have to be prepared for. The assignment's a little longish, so I'm going to give you the rest of the time to work on it, and I'm going to have a few of them chopped off. So everybody try to find it, please. it is 4.3.1. The first couple questions are very important, so I want to leave 1 through 6 on there alone. But I'm going to, here, I'll put it up on the screen here. Once we get into 7, 8, 9, 10, 11, 12 kind of land, I feel like you probably have gotten better at it. So I'll have you skip 10, 11, and 12. Cross those off here. Problems 10, 11, and 12. And when we get up into the 13, 14, 15, 16 range, once you get the idea that this is ASTC, if I were you, I'd make your little thing like this, ASTC, on your paper right there, just to remind yourself. Then I feel like 13, 14, 15, and 16 they're going to go so fast that I don't think we need to cut any out. You know what I mean? They're like no-brainer questions from there. Do you get that when they say like 3 pi over 2 to 2 pi, that's from here to here? So it's in that little zone for this last one, for example. Okay. All right. Then 17, 18, 19, and 20. Determine the sign of the given value. Notice they don't ask you to figure out the exact answer. They just want to know, is it positive or negative? So if they say cosine of 143, do you know about where 143 is? It's less than 180, more than 90. It's somewhere in there, right? If we're doing cosine of it, we should know that sine's the only one that's going to come out positive in there, right? We're in this little zone. In that zone, only sine comes out positive. So all they care about is the sign, the SIGN, positive or negative. Then it's got to be negative because sine's the only one that comes out positive in here. So if I'm in there, it must come out neg. Tangent of 192. All right. Well, it's more than 180, so it must be like in there somewhere. Okay, tangent in there. Oh, tangent in there. It's t in there. What do I know? Positive. Okay. Now the next part. Choose which point would be on the side. We just did that at the end of my lesson there. And if you know where a 45-degree angle is, again, a picture's worth 1,000 words. I would draw yourself a 45. And your 45, I'll do it with a different color. Since you have an iPad, you could do the same thing. And say, there's my 45. Okay. Which of these points could be on that? This, or this? What do you think? Come on, it's a no-brainer. Just say it if you know it. It's got 2, 2, so it's A. That could be on it. All right. This one's 2 pi over 3. We talked about that one before already. So anyway, that's not too rough either. So we skipped a few, but these are such easy ones at the end that you don't need to skip any. They'll go fast. Okay. That's all I got for the lesson for today.